Welcome to SciTrends. I'm Eva Snyder. Now, you probably don't think twice about doing this. Just turn on the faucet and the water comes out. But that water has to come from somewhere. And in California, it's getting harder and harder to find. They're in the middle of a huge drought that's gone on for years. And with lakes and rivers drying up, how do cities like LA and San Francisco keep their faucets running? Well, I went to the West Coast to find out. So tell me where we are right now.
We are at Folsom Lake, which is the state's 9th largest reservoir, and it's sort of dwindled down to almost a puddle. I haven't seen it like this. I haven't seen that island out there. It's really kind of scary.
Amy Quinton is an environmental reporter in Sacramento. She says that just a few years ago, the spot where we're standing was under 150 feet of water. Today, it's like a desert, and it'll take 3 or 4 years of heavy rain and snow just to bring it back to normal levels. That might not happen anytime soon. So, in the meantime, where can California turn for water? Amy has an idea.
I do. I think water recycling is actually one of the best things you can do.
Yep, recycling, as in using water from this. Every time that you flush a toilet, more than a gallon of water goes down the drain. But all that water could be reusable, if we could clean it. Right now, it ends up in sewage treatment centers like this one. So what is this?
This is the raw sewage that coming into the plant, 1.4 million people.
Wow.
It comes from...
Mike Darcy is a wastewater superintendent in the San Francisco area. He's a guy that knows his sewage.
But I must admit, this is not what I thought sewage would look like.
Yeah, at this point, the waste is all combined to a liquid, and at this point we screen it out. First step is screening out the solids.
But this still has the solids
This
in it?
has the solids still in it.
Yummy.
Yes, it is.
Taking solid stuff out of the water isn't so hard. You just need a giant screen.
These are the solids that have settled out from about the first step of processing the sewage. So as you can see, we've got some corn in here, I've got some tin foil.
But there's still tiny microbes, viruses, and other nasty stuff in the water. Existing treatment plants can take most of that out, but they still can't bring it up to drinking standards. So what's left is usually just dumped out.
Normally that water would go directly into the San Francisco Bay.
Miguel Silva is an engineer at the Silicon Valley Advanced Water Purification Center. It's a new plant near San Francisco that makes sewage water drinkable again. He says the process might be one solution to California's drought.
Recycled water is something that's continuously available every year, whether it's a dry year, critically dry year, or below average.
But how do you turn this into this? It's a complicated process, but Miguel walked me through it. Once the water comes out of a normal treatment plant, it's sent here. Each of these tubes holds thousands of long, stringy microfilters that clean the water even more.
So this is what the water is getting pushed through, right?
Yes, yes. It has to make its way inside the hollow fiber in order to get clean. And so here you're removing a lot of the protozoa, the bacteria, and most viruses and debris.
In other words, it takes out anything left in the water that can make you sick, but it can't remove dissolved minerals like salt, so the water is still undrinkable. Taking that stuff out involves a second process called reverse osmosis. A gallon of seawater has about this much salt inside, and removing it all takes a lot of energy. But reclaimed sewage, it's more like this. And that means it's actually a lot easier to take out with reverse osmosis. First, Miguel and his team pump water up to high pressure and then force it through a membrane like this.
It's hard to believe the water actually goes through this. Like, to me, this just feels like, I don't know, a thick piece of paper.
A very, very, very small pore size, 0.1 nanometers in size.
That's so small that it filters out almost anything bigger than a water molecule.
To give you a sense of scale, let's say this is a water molecule. A salt molecule, 10 times bigger. A virus, 100 times bigger. And bacteria, 10,000 times bigger.
After reverse osmosis, the plant takes out any leftover gases and sterilizes the water with UV light. So I guess that leaves just one big question. Can you really tell the difference between this and this?
Perhaps you want to take a taste test. We have 2 water samples. One of them is from tap water, and the other one is purified water from this plant.
Here we go. I honestly can't tell you the difference. It tastes exactly the same. I don't know.
That's pretty impressive, especially since that cup of water looked like this a few days ago. But as clean as it is, the Advanced Purification Center isn't allowed to put their water back into the city's drinking supply. They're already using it for non-drinking purposes though, like golf courses, landscaping, even Levi's Stadium, where the 49ers play.
This is a demonstration plant. So the idea is to demonstrate to ourselves, to the public that we serve, the community that we serve, and the regulators that we can do this reliably, cost-effectively, and that we can meet drinking water standards.
There's definitely still a gross out factor, but so far Miguel and his team have taken raw sewage and made it cleaner than existing drinking water. And in the next few years, recycled water could play a big role in helping keep California's taps from going dry. For SciTrends, I'm Eva Snyder.